Today we are going to do neutralization reactions. The question is, if 25 centimeters cubed of 0.1 molar dm cube hydrochloric acid and necessary to neutralize 65 centimeters cubed of a solution of NaOH, calculate the mass concentration of the NaOH solution. Whenever you do neutralization reactions, you write out the equation first. I have here the equation, and it's neutralization, so you know water should be coming off. And we have two things. We have a base and we have an acid, and they're both strong. The equation is such that HCl, which is aqueous, plus NaOH, or sodium hydroxide, which is aqueous, will react together. Sodium and chloride will be made, which is aqueous. Basically, that's salty water. And then we're going to have water being given off, which is the neutralization factor. After you do your equation, you write your ratios. Okay. Since we have no numbers in front here, it's going to be a 1 to 1 to 1 to 1 ratio. Okay, so our calculation should be pretty easy, seeing as we have just a 1 to 1 ratio. And we know from the question it says, if 25 centimeters cubed of a 0.1 molar dm solution of hydrochloric acid, right? And we know this is how much was necessary to neutralize 65 centimeter cubed of a solution of sodium hydroxide. So therefore, we're going to work out the amount of moles in HCl that was necessary. So, if we have 25 centimeters cubed, we divide that by 1,000 centimeters cubed and multiply it by 1 dm cubed. Right, that's your concentration. This is your volume, sorry. Right? You multiply the concentration, which is 0.1. And this is all to give you the moles of HCl used. Okay, with that we calculate 25 divided by 1,000, alright, will give you 0.025, and multiply that by 0.1, and will give us 0.0025 moles. And we should have, this should be equal to 0.0025 moles of HCl. How do we know it's moles? This cancels out, this cancels out. You're left with that. This cancels out, this cancels out. You're left with that. That is why you always use units to ensure I'll keep you on track. Now from the equation above, we know theoretically 1 mole of HCl react with 1 mole of sodium hydroxide. So if we have 0.025 moles of HCl neutralizing 65 centimeters cubed of sodium hydroxide, and it's a 1 to 1 ratio, we would have the same amount of NaOH. So let me write that down now. Since we know that HCl reacts in a 1-to-1 ratio with sodium hydroxide, you're going to have a 1-to-1 ratio. And if we just figured out that 0.025 moles of HCl will react with X. And since it's a 1-to-1 ratio, basically your ratios are written like 0.0025 equal to 1 over X. And we know everything is in moles. X is basically equal to you cross multiply, and you bring this down. So X is going to be equal to 0.0025 times 1 all over 1. That goes, and you're left with just this, moles of NaOH. So now that we have the number of moles of NaOH in 65 centimeters cubed, we use the same equation that we used a while ago, where concentration times volume is equal to number of moles. Right? And we know from the question that 65 centimeters cubed of NaOH was used, and we're going to convert that to decimeters cubed, and we're going to get 0.065 decimeters cubed. And we also know the number of moles, which was 0.0025 moles of NaOH. And since we're looking for concentration, right, we're gonna basically divide this side by volume and divide this side by volume to get rid of the volume, and is now equal to concentration in moles over volume. And since we have the moles of NaOH, 0.0025 moles, and you keep units, divided by 0.065 decimeters cubed. What we do now, we just find the answer, and we already know we are correct because we have moles per dm cube, which is what the units are for molar dm cube. We're going to divide 0.0025 divided by 0.065 to give us 0.038 moles per dm cube. However, we didn't finish. The question asks for mass concentration. So if 1 mole is equal to the molecular weight of anything, then 1 mole of NaOH would be its molecular weight, which is actually 23 plus 16 plus 1. So then therefore 1 mole of NaOH contains 40 grams per mole. Right? And therefore if we have 0.038 moles per decimeters cubed, we can very well find out the grams. So then therefore X will be equal to 0.038 moles per dm cube times 40 grams per mole and we now have mass concentration times 40 gives you 1.5 grams per dm cube. And we can do a recap. We can do it again and say 0.0025 divided by 0.065 is equal to 0.038, right? Multiplied by 40 gives you 1.5 grams per decimeters cube. And that's your answer. I hope this helps. Stay tuned for my other question, neutralization reactions.